Right, okay, we're looking at transformations with matrices now, and essentially this is multiplying matrices, all right? So here we go. I'm going to take my transformation matrix, which looks like this. What's that? 4, 1. And this coordinate I'm going to put as a position vector, okay, which is essentially just the same as sticking it on its head, all right? So there you go, that's a position vector there. Now then, I just do exactly what I've done before. So 2 times 3 is 6, minus 1, which is 5. 4 times 3 is 12, plus 1 is 13. There you go. Now the next one is a little bit trickier because we've got to work out what A and B are. So we're going to do 3 and negative 1. And we know that equals 9, 15. Actually, I don't know why I'm writing the 9, 15. Don't need to write the 9, 15. So what I'm going to do is do this. So what's that? A, B, 3A minus B. And that gives me, right, 3A minus B, and it gives me 9A plus B. And I know that 3A minus B equals 9. And I know that 9A plus B equals 15. Okay, so I'm going to add those two together. I end up getting rid of the B's, don't I? So I get 12A equals 24. So A's got to be 2. Now I know that A's 2. I get B is minus 3. Okay, because 3A's are 6, but I want 9 minus 3, as it were, is 9. So it's just simultaneous equations after that. Now then, this sort of thing. Now, what I do this in a slightly odd way, but it kind of works. I'm going to apply this transformation to the point 2, 1, and I'm going to see what it does to the point 2, 1. Okay, so here we go. Right, so it's going to go 2, 1. And the reason I don't use 1, 1, right, is because various different transformations will give you the same result. And so I use 2, 1 so that I can tell which way up stuff is. So this goes to 1 minus 2. So what ultimately has happened is that 2, 1, which is about there, has gone to 1 minus 2, which is down there. And so therefore, what has actually happened is a rotation 90 degrees clockwise. I can't fit. Oh, actually, I might just be able to fit Y's in there. 90 degrees clockwise, centre the origin or 0, 0. Okay, 0, 0. There you go. Right, so I find that actually it works better to use this point because then you can tell what's happened to it. All right. Now, the last one, okay, what we got to do is, you know, the original unit square, all right, it's called a unit square because it's 1 by 1 is 1 centimetre squared, or 1 unit. Actually, I should put unit squared. It's not necessarily a centimetre, is it? So 1 unit squared, okay, unit squared. And that's gone to 49 centimetres squared. So I suppose I could have put centimetres squared originally, couldn't I? Anyway, what I've got, so you've got to remember that it has enlarged, okay, 7 in one direction as well. It's 7 because that's 7 squared. So it's gone in one direction and 2 directions because it's an area. So you've got to multiply by the scale factor squared. So I've got to square root 49 to give me 7. All right, so K has got to be 7. All right, but there you go. It is essentially just multiplying with matrices, but they're transformations and coordinates. All right, enjoy.